Hello students. In the chapter Rotational Dynamics, today we are going to discuss about banking of road. In the previous period, we have seen on unbanked road, the maximum safe speed is given by V max is equal to under root of mu rg. In this equation, mu is the coefficient of static friction, r is the radius of curvature of the road, and g is acceleration due to gravity. This r depends on the situation where the road is being constructed. G depends on the place. We know that it is acceleration due to gravity and it has a fixed value for a given place. Mu is coefficient of static friction. If we increase mu, then the velocity can be increased. But for increasing mu, we have to make the road surface rough. If the road surface is made rough, then it causes wear and tear of the tires of the vehicle. Therefore, we cannot increase this mu much. There is a limit up to which mu can be increased. Also, we should not depend on this mu because in rainy season the mu decreases, or if the oil is sprayed on the road surface, it becomes smooth, that is mu decreases. Hence, best way to drive safely on a curved road is the banking of the road. What is this banking? The previous formula was for a horizontal curved road. The road is curved, but the surface is horizontal. Now, we are considering a road such that it is tilted. Its outer edge is raised with respect to inner edge. Suppose here the road is taking a turn towards left hand side like this. This is the center of the circle on this side and this is the width of the road. The road is taking a turn towards left hand side. We are driving on this road. Now, this is the height h. It is called as elevation. In order to find this elevation, we use this triangle. In this triangle, sin theta is equal to opposite side, that is h, upon the width of the road L. Hence, h will be equal to L sin theta. From this equation, we can find out the elevation of this road. Now, we are going to find out the safe speed for driving a vehicle on this bank road. While deriving the equation for the safe speed, we are considering here that there is no friction, there is no air resistance. What are the different forces then acting on the vehicle? One of them is mg and another is the normal reaction N. Here, we are going to consider the vehicle as a point mass. This is the center of gravity or center of mass of the vehicle, and we are going to consider that the complete vehicle is replaced by this single point. Hence, I have shown the normal reaction N from this point and also the weight mg from the same point. In order to find out the resultant of these two forces, that is the weight mg, m is the mass, g is the acceleration due to gravity as usual. It is the weight of the vehicle. Mg is the weight of the vehicle which is acting vertically downwards. And normal reaction is always normal, that is perpendicular to the surface. Here, this is the horizontal and this is the road surface which makes an angle theta with the horizontal. This is a vertical line. So, there is angle of 90 degrees between the horizontal surface and this vertical line. Similarly, this is the road surface and normal reaction is perpendicular to the road surface. We know the property that angle between two surfaces is the same as angle between perpendiculars drawn to these two surfaces. This is horizontal, this is perpendicular to horizontal surface, this is road surface for bank road, and this N is perpendicular to the road surface. Hence, this angle is theta. Now, I am going to complete the parallelogram here. This is the diagonal of the parallelogram. Hence, these two will be perpendicular component of the normal. I am going to resolve this N in two components in order to find out the resultant of the forces mg and N. So, I have now resolved this N. This is the adjacent side, therefore, it will be N cos theta, and this is the opposite side, it will be N sin theta. This side is parallel to the upper one and they are equal in magnitude, therefore, this side will be N sin theta. Thus, we have resolved the normal reaction N into two components, N cos theta and N sin theta. Whenever you draw the diagram, please remember that this weight mg is balanced by this component N cos theta. Therefore, you have to draw this length from center of gravity and this length for mg from center of gravity equal. Because they balance each other, they are equal in magnitude and opposite in direction. Hence, we write mg is equal to N cos theta. So, which one is unbalanced force? It is N sin theta. And N sin theta is directed towards the center of the circle. This is a bank road. It is taking a turn towards left. The center of the circles will be on this side, on left side. And N sin theta is also pointing towards the left. Therefore, it provides the centripetal force which is required for circular motion. Hence, we write mv square by r. What is mv square by r? It is the centripetal force. Centripetal force required for circular motion. It is provided by N sin theta. So, this is our second equation. Now, I am going to divide equation number 2 by equation number 1 to obtain mv square by r upon mg is equal to N sin theta upon N cos theta. Here m cancels. So, we get v square upon rg on left hand side. On the right hand side n cancels. Therefore, we get tan theta, sin theta upon cos theta is tan theta. Hence, the equation becomes v square upon rg is equal to tan theta. This is an important equation for us. Because if we want to find what is the angle of banking theta, then from this equation we obtain theta as tan inverse of V square upon Rg. Whenever the engineers construct the bank road, in order to find the angle of banking, this equation will be very helpful. Now what is the speed? Once we have banked the road, then we have to find out the set speed with which the vehicle can be driven on this bank road. For that again we shall use equation number 3. So from equation 3, V square is equal to Rg tan theta. I am going to transfer this term to the right hand side in order to obtain equation for V square. V square is equal to Rg tan theta. Therefore, V is equal to, taking square root, we get V is equal to under root of Rg tan theta. So this equation number 5 gives us the set speed in order to drive the vehicle on this bank road. We cannot always drive with the exact speed given by equation number 5. Therefore, what is the lower limit? What is the upper limit of the speed? This we are going to calculate right now. The most safe speed is given by V safe is equal to under root Rg tan theta. If the speed decreases than this value, then the vehicle on this bank road has tendency to slide down towards the center of the circle. Now the frictional force comes into existence and it acts in exactly opposite direction to that of direction of sliding. That is, the force is acting along the surface of the road, but it is along the angle theta as shown in the figure. The force of friction always acts along a surface where there is contact between two surfaces. Here the wheels of the vehicle and the road surface are in contact, therefore Fs is shown in this manner. In order to balance the different forces, we again resolve this Fs into two components. Now this is the road surface and I have shifted this horizontal at this point of contact. Hence, this is the same line and I have drawn a parallel line to this. Hence, this angle is theta. The opposite side naturally will be Fs sin theta. So, this side and this side are of equal magnitude. Therefore, this is Fs sin theta. And this one is the adjacent side of theta. Therefore, it is Fs cos theta. Here, we are observing that n cos theta and Fs sin theta are in the same direction. I can shift this vector parallel to itself. Means I can keep the starting point of this vector at the center of gravity. So these two vectors n cos theta and Fs sin theta will add together and they will now balance mg. So as they are in the same direction, we will have to add Fs sin theta to n cos theta, and under balance condition we have to equate the addition of these two forces to mg. So in this equation, in this diagram rather, we have to write the equation mg is equal to n cos theta plus Fs sin theta. Then this n sin theta and fx cos theta are exactly in opposite direction. As for circular motion, centripetal force is required. This n sin theta must be greater than this fx cos theta. So the resultant centripetal force, in this case let V1 be the velocity with which the vehicle is being driven. So mv1 square upon r is equal to subtraction of these two forces, n sin theta minus fx cos theta. This is equation number 1 and this is equation number 2. Now I shall divide equation number 2 by equation number 1. So we will obtain mv1 square upon r divided by mg is equal to n sin theta minus fx cos theta divided by n cos theta plus fx sin theta. As the speed goes on decreasing, there is more and more tendency of sliding of the vehicle. Hence, the force of static friction is a self-adjusting force. It will also increase. As the velocity decreases, this frictional force also increases. Hence, the maximum value of this frictional force, as we know, is mu s into n. Hence, let us substitute for fs n sin theta minus mu s n into cos theta divided by n cos theta as it is plus mu s into n into sin theta. Now n is contained in each term on the right hand side. Therefore, let us take n common. In bracket sin theta minus mu s cos theta divided by n common again cos theta plus mu s sin theta. So n will cancel with this n. Now let us divide the numerator and denominator on right hand side by cos theta. So we shall get sin theta upon cos theta minus mu s cos theta upon cos theta divided by cos theta upon cos theta plus mu s sin theta upon cos theta. Hence, here m will cancel to give this 1 square upon rg. Hence, we shall get v1 square upon rg is equal to sin theta upon cos theta is tan theta. So, tan theta. Then, cos theta cancels, giving us minus mu s divided by cos theta upon cos theta is 1. Sin theta upon cos theta is tan theta. So, 1 plus mu s tan theta. This is the value of v1 square upon rg. Hence, v1 square will be equal to Rg multiplied by tan theta minus mu s divided by 1 plus mu s tan theta. Now in order to find out V1, that is the lower speed limit, let us write square root of this equation. V1 is equal to under root of Rg in bracket tan theta minus mu s divided by 1 plus mu s tan theta. So this equation now gives us the lower speed limit, that is the minimum speed with which we can safely drive the vehicle on bank road. Now if we compare this equation and V-safe equation, then here you are observing that in the numerator there is tan theta minus something, means the numerator has been decreased. On the other hand, in the denominator there is 1 and here there is 1 plus mu s tan theta, means the denominator has been increased here, so that the value of V1 will decrease. So V minimum is equal to under root of Rg in bracket tan theta minus mu s divided by 1 plus mu s tan theta. V will become 0 if this numerator becomes 0. Therefore, if mu s is greater than or equal to tan theta, then we can drive the vehicle with very low speed. For this, the angle of banking should be small and the road surface should be rough. So this equation gives us the minimum speed with which we can drive the vehicle on the bank road. The angle of banking is theta in this case, and Vs is the coefficient of friction. Then we shall find the upper limit of the speed. So let us find the upper limit of the speed. The most safe speed is given by V safe is equal to under root Rg tan theta. If the speed exceeds this limit, then the centrifugal force is greater than the component n sin theta. Therefore, the vehicle moves away from the center of the circular track. Here, the frictional force again plays its role. It acts in opposite direction to the direction of sliding. Hence, the force of friction now acts along the surface where there is contact between the wheels and the road surface. So this is the direction of Fs now, that is the force of friction. This force of friction again we resolve into two components. One is vertically downward and another is a horizontal component in this direction. In this case, as we are observing here, n sin theta and fs cos theta are along the same direction, and fs sin theta and mg are along the same direction. N cos theta is opposite to mg plus fs cos theta. For stability of the vehicle, the addition of these two forces must be balanced by n cos theta. Means we will get the equation mg plus fs sin theta is equal to n cos theta. Hence, mg will be equal to n cos theta. This is plus, so on this side it will be minus fs sin theta. Again, the another equation is for centripetal force. Here, this n sin theta and fs cos theta, they add together to form the centripetal force. So, m v2 square now upon r is equal to n sin theta plus fs cos theta. This is equation number 1 and this is equation number 2 now. Again we divide equation 2 by equation 1 and obtain again here we cancel v square upon rg is equal to n sin theta plus fs cos theta divided by n cos theta minus fs sin theta. Now the maximum value of this frictional force is mu n. So mu s into n. We shall substitute here n sin theta plus mu s into n into cos theta divided by n cos theta minus mu s n sin theta. N is common, so it will cancel. Again we shall divide the right hand side in numerator and in denominator by cos theta. So we shall get sin theta upon cos theta is equal to tan theta plus mu s cos theta upon cos theta will be 1. So only mu s will be there upon cos theta is 1. N cancels in the numerator and denominator. So 1 minus, now sin theta upon cos theta is tan theta, mu s tan theta, n is common and it will cancel in numerator and denominator. So this is the equation for V. Here we shall call it 2. V2 square upon Rg. So V2 square will be equal to Rg in bracket tan theta plus mu s divided by 1 minus mu s tan theta. Compare. Now we shall take square root of this to get V2. V2 is equal to under root of Rg in bracket tan theta plus mu s divided by 1 minus mu s tan theta. Now again compare these two equations. Equation number 3, we may call it, this is the upper speed limit. When we compare these two equations, in the numerator there is tan theta plus something, means numerator has been increased, and in the denominator there is 1 minus something, that is denominator has been decreased, so that the value of V2 will be greater than this V set. Here, if we make this mu s into tan theta equal to 1, then the denominator becomes 0. Hence, V2 is equal to 0, then what will happen? This will happen when mu s is equal to cot theta. That is, V2 is equal to infinity, V2 is equal to infinity means we can drive with any speed on this bank road if mu s becomes equal to cot theta. Cot theta into tan theta is 1, 1 minus 1 is 0, 1 upon 0 is infinity. That is, we can drive the vehicle with any speed on the road if mu s is equal to cot theta. This gives us the value of theta as equal to 45 degrees, or if it is greater than 45 or equal to 45 degrees, then the value of V2 is infinity. But when we keep this value of angle of damping equal to or greater than 45 degrees, then there is limit on the V minimum. So in this way we have found out the most safe speed V, the lower limit, that is minimum speed for the vehicle to be driven on the bank road, and the maximum speed limit which is given by this equation 3 here now, just now. So using these equations we can find out the most safe speed, the minimum speed. If theta and mu are given, then we can find R is also given, then we can find out V minimum, as well as the V2 means the maximum speed, that is the upper speed limit. So let us stop here. The remaining things we shall discuss in the next period. Okay, thank you.